This section on simple formulas and literal equations is we're using the same processes as last time with those properties of equality. We'll just solve it. We'll just use them to solve for a variable. So we'll have multiple variables. So a literal equation is an equation with more than one variable. So for example, voltage is the current times the resistance. We'll use that one. V equals I times R. You got three variables there. Here's some other literal equations. A, Y plus B equals 2C. It looks like we have A, B, C, and Y. And what they want us to do is to solve for the given variable. So we're going to solve for B right there. So we want to isolate B. So we're going to get rid of this AY. So we're just going to subtract AY from both sides. And so we have B equals 2C minus AY. We just solve for B. So a conductor is a material that permits the flow of electrons. Resistance is a measure of the resistance to that flow. At a given temperature, the resistance of a material is dependent on the type, length, and cross-section as given by this one. Where you got R rho times L all over A. And we want to solve for that A on the bottom. Well, the problem right now with the A being on the bottom is I got to have it on the top. Right, I got to solve for, so I got to get it on the top. So what I'm going to do is I'm going to multiply this side by A, so it cancels, and that side by A. And so now what we have is we have AR on the left equals rho times L, P times L, if you will. And again, we're solving for A, so we got to get rid of R. Well, right now we're multiplying by R, so I'm going to go ahead and divide out the R on both sides. And so we have A equals rho times L all over R, and now we've just solved for A. All right, this next one we're going to go ahead and solve for L. So let's go ahead and distribute that. M equals RL minus RX, and we're solving for L. So let's get rid of Rx. So add Rx to both sides. So we have M plus Rx equals RL. Oops, R capital L. And we're solving, remember, we're solving for the L. So right now we have R times L, so we got to divide out the R. Both sides. So we have L equals M plus Rx all over R. Or you could also write it this way. This is also true. That's a common denominator. And notice the R's cancel. So this is also another way to write that. Either one is true. All right, let's solve this one for capital B. So we go ahead and distribute that there. Q equals KAB. Oops, that's a terrible B. Minus KAC all over L. And we're solving for B. So the first thing is we got to get rid of the L. Let's multiply both sides by L. So we got QL equals KAB minus KAC. Again, we're solving for B. So we got to get rid of the minus KAC. So let's add it. So now we have QL plus KAC equals KAB. QL plus KAC equals KAB. Again, we're solving for B. So right now I'm multiplying by K and A. So I got to divide out K and A. Both sides. And there it is. B equals QL plus KAC all over KA. Or if you want to use the fact that that's a common denominator, you could write it this way, because the K's A's cancel. So either of those is correct. Do one more here. Let's solve this for S1. Okay, S1. Well, And notice there's an S1 on the other side, so we got to get all the S1s together. Let's get all the S1s together. Well, these are like terms. So 1 AS1 minus 3 AS1 is a negative 2 AS1 plus CS subscript 2 equals 3A squared. Again, we're solving for S1. So let's get rid of the CS2, both sides. So we have negative 2AS1 equals 3A squared minus CS2. Now I'm going to divide by negative 2A, both sides. So I have S1 equals 3A squared minus CS2 all over negative 2A. Now you don't want to have a negative on the bottom, so go ahead and take that up top. And let's go ahead and distribute. So I'll have negative 3A squared plus CS2 all over 2A. In other words, I'm going to write the CS2 first, minus 3A squared. So my first term's positive. Okay, so CS2 minus 3A squared all over 2A. And that's all it is for solving simple formulas with literal equations for a variable. Okay, see you next time.